Hello everyone. Well, we have come to the second episode about electricity. In the first part, there was a quote that many doubted. For skeptics, we quote, "It is not necessary to define clearly what electricity is at the moment. Today, we cannot give a clear definition of the concept of electricity. I think it's definitely not worth joking about the mental abilities of a scientist of this scale, but it is definitely necessary to express respect for the fact that he dared to speak out openly. After all, you don't hear this every day from the monoliths of science who write textbooks for us." Speaking of textbooks, in the first part there were several experiments on electrostatics, but few people paid attention to the fundamental contradiction. In any physical science textbook, you can find an example of how static electricity occurs if you rub a woolen cloth on ebonite. Literally, the following is written: electrons flow from this woolen cloth to ebonite. An excess of these electrons charges ebonite negatively. Seems clear and obvious. But what about the fact that ebonite is a dielectric? Just a few pages later in the same textbook, we learn that the electrons in the atoms of dielectrics are firmly held in their places and cannot move. What do we observe then, when we rub this poor tube with a woolen cloth? This contradiction is also confirmed by the experience of the location of the charge in the capacitor. So do dielectrics have something to do with electricity, or not? We'll wait for expert opinions of experienced electricians in the comments under the video. They will definitely explain it. And while they are writing angry comments, here is a quote from one of them, who hasn't been with us for a long time. This is what he said: 80 years have passed, and I still ask myself the same question. What is electricity? But I'm unable to answer it. This electrician's name was Nikola Tesla. And now, let's touch on, so to speak, the basic concepts. Or rather, those concepts that, in fact, are being passed off as basic today. We will talk about particles and about the main one, the electron. Today, physicists talk about it as something that exists objectively for sure. For example, we have all heard about the electron microscope. But who said that this microscope sees exactly electrons? In fact, this device is simply able to distinguish smaller details. Also, everyone has heard about Wilson's camera, but in fact, no one has ever seen the electron itself. In reality, there is only a physical model recognized by science, which seems to be the most understandable explanation of physical phenomena at the moment. Let's try to figure it out. In 1897, Joseph John Thomson announced the discovery of the electron when he conducted his famous experiment with cathode rays. Later, he even received the Nobel Prize for it. Decades later, something appeared that had been available in every house until recently. We are talking about a TV with a kinescope or an electro-ray tube. According to scientists, the principle of operation of this device specifically shows us what an electron is. But this is not quite true. Let's imagine a simplified model of a kinescope. Here is the cathode, and here is the annular anode. Now, let's connect the simplest electric current generator to all this and close the circuit. The generator is a conductor frame placed in a magnetic field. If you start rotating it, there will be tension. Scientists have found that when a high voltage is applied, something in the tube begins to actively shoot in separate portions. Here it is, the electron. This is what they decided after consulting and began to convince the whole world of this. But here's the weird part. No electrons are born in the generator. The device as if pushes through a closed circuit those electrons that are already in the material of this circuit. And in the cathode ray tube, they continuously fire like a machine gun. Logically, electrons should be lost. It will run out eventually, like a supply of ammunition during shooting, but they still come from somewhere. Where from? And it also turns out that in metals, electrons freely leave their nuclei and somehow move en masse under the influence of the applied voltage from positive to negative. But sooner or later they should have a migration crisis. If this were the case, then the metal would change its properties over time when an electric current passed through it. But the wires have been hanging for centuries, and nothing happens to them. Another question hanging in the air is how many electrons there must be in an electric current in order for them to be able to do a certain job. For example, we will power a light bulb from a battery. According to the available theory, this is what happens. The electrons supposedly break away from their nuclei and rush along the wire into the spiral of the light bulb, heating it to very high temperatures. Their goal is to increase the number of photons emitted by the spiral that electrons actually turn into, so that they are enough for full-fledged illumination. But let me ask you, Where in a small battery in a thin wire that connects it to a light bulb can such a huge number of electrons come from to be converted into photons for a long period? The circuit is closed. Let's add to this an interesting point from chemistry textbooks. They say that the external electrons in the atom are responsible for valence or chemical bonds. That is, under certain conditions, one atom, approaching another, interacts and forms a molecule. This is the cornerstone in the theory of chemical bonds. There would simply be no chemistry without it. And now, let's take a look at a physical science textbook. It says that in conductors, external electrons, poorly held by the nucleus, allegedly descend from their orbits and idly travel throughout the material. For example, through copper or steel wire. It turns out that chemists claim that all electrons are neatly spread out and are responsible for chemical bonds. And physicists, in order to explain what an electric current is, let the electrons float freely. Moreover, they do not even swim at a snail's pace but much slower. It is officially stated that the speed of an electron in a conductor from plus to minus is 20 times slower than the speed of a snail. Some kind of lazy bums, those electrons. Why are chemists silent about such a blatant outrage? Probably, they do not want to get involved with physicists, because it is impossible to reconcile these opposing theses. It's not as smooth as it seems at first glance with photons either, to put it mildly. We heat the metal and it begins to glow. The atoms go into an excited state and emit energy. And which of them starts moving faster? The atom itself, or the electron? And why is it obliged to slow down if it is heated? According to the theory, when experiencing breaking, it emits a quantum of light. By the way, science does not give a clear answer. You can look for yourself. Maybe you will show off your knowledge in the comments. Well, let's leave the simplest issue of temperature glow. There is another way. Here is a quote from the textbook. The mechanism of the LED glow is fundamentally different from the mechanism of the light bulb glow. An LED is a contact of two semiconductors. In each of them, electrons can have only a certain amount of energy and occupy certain energy levels. In one of the semiconductors, this level is higher than in the other. When the current flows in one direction, the electrons, passing the boundary, jump from a higher energy level to a lower one. The excess is emitted in the form of light. There's no heating up at that time. Each color should have its own threshold, so this difference determines the specific frequency of light. But according to this theory, there can't be a white LED that emits in the entire frequency spectrum. Well then, what is the color white at all? The definition is as follows. It's a color with a spectrum of electromagnetic radiation of uniform power over all wavelengths in the visible part. That's what it looks like. But we do not observe fixed frequencies here, which should in theory follow the formula. The photon energy is related to the frequency through Planck's constant, and the spectrum should be discrete, at least like this. We return to heating. Iron. 28 electrons. When heated, all atoms are heated to the same temperature. These 26 electrons were supposed to generate a discrete spectrum when heated according to the formula. Well, is your brain boiling yet from all these theoretical wilds that were so clear and apparent at school? But that's not all. Let's look at this device. A distinctive feature of this engine, which is called the Milroy engine, is that it lacks magnets and circuits, which are present in all conventional engines. That is, the shaft does not repel from anything. And the most interesting thing is that any dummy can assemble such an engine. Another phenomenon in physics that is a bane of modern scientists is the Hutchinson anti-gravity effect. In 1979, this Canadian researcher was lucky enough to discover several interesting effects. Their essence is that a specific zone is created at the time of operation of high-voltage sources such as Van der Graaf generators or 2 or more Tesla coils. In it, objects either rise into the air or melt, if we are talking about metals or wood. Sometimes metal samples crumble or turn into some other metals. And here is another similar effect, which we've already described in one of our stories about inventions. In a nutshell, Gennady Ignatiev created a 4-meter installation capable of creating such a lifting force that could lift a load weighing 13 pounds with a consumption of 10 kilowatts of electricity. Considering all of the above, only one conclusion remains. The phenomenon on which our entire technocratic civilization is built, of course, objectively exists. But to use does not mean to understand. Man has also used wood from time immemorial, but the fact that it consists of cells was only discovered a few centuries ago. Taking into account the fact that there are more and more contradictions in fundamental physical concepts, maybe it won't be long to wait for the revision of the modern scientific picture of the world, and then this picture becomes very strange. An electron was invented, but a proton and a neutron were needed. And what's wrong with them? you ask? We will talk about this in future videos on our channel. Turn on notifications and do not forget to show this video to your friends. Maybe one of them has successfully photographed an electron and is ready to tell us about it in the comments under this video. See you soon. We cannot clearly define what electricity is. Although strange, it is a fact. And right now, in the electrical encyclopedia, it is very difficult to define the word electricity, for it is so multifaceted and has such a broad concept.